Hi everyone, greetings. I hope you're having a great day. So, before I begin, I would like to greet our honorable judges and fellow time adjudicators. Hi everyone, my name is Danyasri Anaprampuan Ganesan, and I am going to be representing my team today in our project called Safe Steps. So, what is Safe Steps, you may ask? It's basically a walking cane for the blind, but with AI implemented features into it. And so let's head right into the introduction. Every day, many visually impaired individuals face challenges in navigating their surroundings. And traditional walking sticks offer basic support. But is that really what everyone needs? Basic support? We need to do more than that. So, with our Safe Steps project, we plan to use those features, the good features of a walking cane, and innovate it to make it better, such as detect obstacles, water hazards, and low light conditions, which can pose a serious risk. Now, I will be explaining all these features later on in the video. While there are walking sticks with AI powered technology in the market these days, but our main goal is to make it affordable and accessible to everyone. So many of them are expensive and not widely available. So introducing Safe Steps with SDG 3, good health and well-being inspired features, ensuring mobility and safety. And the best part is it's cost efficient, hence making it affordable to everyone and anyone. So basically, the name for our project is because we want to make sure that the stick is actually safe to use for everyone, and it's better for people to use our stick compared to a normal walking stick because our stick has better features compared to it. And before diving right through our stick even further, let me just go through a little bit of background studies. So, based on the records published by WHO, aka the World Health Organization, over 253 million people suffer from from vision impairment, and with 39 million of them classified as the blind. And in my opinion, this is quite a major number of people, and many of them face multiple challenges due to their surrounding on a day-to-day basis. While there are walking sticks with AI powered technology in the market these days, many of them are expensive and not widely available. So, with our most high-tech solution are costly and inaccessible. So, SafeSteps provides a low-cost efficient alternative by integrating multiple sensors for real-time obstacle detection, water sensing, and location tracking. So our main objective basically for this project is to make sure that everyone has a sense of safety and independence on walking stick, because we want to make sure that everyone is included while using our walking stick and no one gets left behind. That is why our main goal is cost efficiency and highly marketable it. And our objectives are to identify wet surfaces using water sensors to prevent slipping, enhance visibility in the dark using an LDR sensor that activates in the dark. This is because, like for example, you might be wondering why blind people need light sensors. Well, basically, it's not for them, but it's mostly to do with the other motorized vehicle drivers on the road. Like for example, when a blind person walks on the road and the car can't see them because they're dressed in black or something, like dressed in dark clothing. And what our stick does is our stick emits light with our light sensors. Like for example, our stick detects darkness in the surrounding area, and it lights up so that motorized vehicles passing by can see them and not have accidents. So this is very crucial actually to prevent accidents. So majorly for safety, and besides that, it offers an affordable and scalable solution for global accessibility. So with our project, you can expand it worldwide because it's easily profitable for once. And now we're gonna head right through our methodology. So at first, we focus on component selection and integration. So what we do is we take our microcontroller, and for this, we are going to be using our Arduino Uno because this is just a prototype so far. So the Arduino Uno is for sensor processing, and for obstacle detection, we are implementing an ultrasonic sensor that detects distances to generate warning signals. And for water sensor mounted at the cane at the bottom. So basically this water hazard sensor is, for example, there is a puddle of water on the road, and a blind person wants to walk on the road, but they can't detect there's water in the road, and eventually, unfortunately, they might end up stepping on the puddle, making their shoes wet, and etc. So with our invention, we can prevent this from happening and make sure that they are dry and safe, and they feel comfortable to walk on the road even more. And besides that, we also have GPS tracking. We use the Neo 6M module to send location data. So this is very crucial because if you want to track someone, you're worried about them, you're worried about someone blind who's walking on the road, and you just want to track them basically. Police can use this GPS tracking sensor because to check their location and where they are, ensuring that they don't get lost anywhere. And beside that, we have light sensor, as just now I explained. We are going to use the LDR component that activates an LED to provide light in the dark surroundings. And besides that, we also have an alert system, buzzer and vibration motor for user alerting. So basically, this alert system is crucial in my opinion because, for example, a blind person is walking in quite a crowded area, and they want to avoid hitting other people with their cane, for example. So this our prototype prevents that from happening by emitting a loud buzzer sound, and the distance that we took is basically 2 meters far. And this is because, like, for example, you're walking and a blind person is walking and they're using a cane in a crowded area, and then someone comes too close to them, so this avoids them from hitting that person with a cane or provide any further calamities from happening. And secondly, for our methodology, we're going to be talking about circuit design and programming. So the Arduino serves as an input receiver and alert center for the connected sensors. Precise sensor data processing is achieved through programming in Arduino IDE. The GPS module sends location information to a receiver when an emergency occurs. Like, for example, a blind person is unfortunately, he or she got hit by a car or something else, and it would be easier for the person to be tracked down due to this stick. And this is all thanks to the help of AI, which we also implemented in our prototype. And beside that, for prototype development, the components are securely attached to a walking stick for outdoor operations, and a rechargeable battery powers the system, and this includes on and off switch for operation. And for our testing and calibration part, both individual sensors and their combined operation undergo testing to confirm precise detection capabilities. So here we want to replicate real life conditions such as dark rooms and wet and congested environments. So the reason why we didn't really make a video of showing our prototype is because it's we are currently planning to implement it even more. Right now we are planning to develop it in even more. Right now this is just a testing phase and we are not fully done with our prototype. We are like about currently at this point we're about 75% done with our prototype, but we still have some minor mishaps and we would like to implement it even more, make it 100% go through. Then we will like to demonstrate it when it's fully developed. And so for our final development and testing, the product undergoes testing by visually impaired users and obtain their feedback. So this is what we would like to implement in the future, in the near future, hopefully. Because once we're 100% done, we plan to give it to the actual blind people to test it out. And here we have our table just to show a graphical version of it. So we start with the sensor initialization and then obstacle detection. So it vibrates with the buzzer alert, and then water detection. It sends water alerts. Light detection, yes, it turns on. And emergency, yes, it sends GPS system. So, before I conclude, I would like to give a shout out to the references which I took for this particular project, which is the WHO 2022 Visually Impaired and Blindness, and also a huge shout out to DWK Ng and SY Go, an indirect control of autonomous wheelchair BCI. So basically we took their data and implemented to ours to make it perfect. And that's it for this video. I hope you guys enjoy, and remember, think safe steps. Thank you and have a nice day.